Now in Learning Objective C, we're going to switch gears and condense the logarithms by applying the properties of logs. Now what they want us to do here is rewrite this as a logarithm of a single number. So when you first see this, one of the things you want to do is clear out any of the numbers and make them exponents. So 2 can become an exponent, so I'm going to rewrite this as log. By the way, it looks like we have base 10 plus log of 5 squared. Now, when we have addition for logarithms, we can condense these together into one. When we do, it becomes multiplication. So this is 40 times 5 squared is 25. I'm going to do that. Now, they said we can get a single number. So what is 40 times 25? Well, that actually is 1,000. So then the question is, what does this equal? If you want to, you can put the base 10 there to help you see it better, and then rewrite this as an exponent. 10 to some power is 1,000. What is that answer? It's going to be 3. So this statement here is actually the number 3. Take a look at this one. Now we have addition and we have subtraction. So I know addition is going to be multiply, subtraction is division. There are no coefficients in front of these to make them exponents, so I don't have to do that. First thing I'm going to do is crunch these two together. So let's write it as log, and this is base 2, and I'm just going to do the 3/5 times 5/2. And then we'll just leave this second part here till we simplify. Remember on fractions, just multiply straight across. Or right here, 5 divided by 5 is 1, so that simplifies out. So now we have log base 2 of 3/2 minus the log base 2 of 3. Now the subtraction crunches together into division. Now be careful, when you crunch these together, it becomes 1 log. I'm only going to write log once. So this is going to be 3/2, and then I divide it by 3. Now to simplify this, we have a complex fraction, so a fraction and a fraction. Let's get rid of the denominator. Multiply by the reciprocal of 1/3. So what we're going to see happen is a few things. That obviously clears out. These 3's here cancel. So what we are left with is we have log base 2 of 1/2. Again, they said this becomes a single number, so I'm going to say it equals something. And if I rewrite this logarithm as an exponent, it's exponent base 2 of something is 1/2. So 2 to some power equals 1/2. What did they raise this to make it a half? Well, whenever a whole number here becomes a fraction, it was a negative exponent. This here is the number -1. So the answer is -1. This long, complicated logarithm is really as simple as saying the number -1. Let's look at this one. Again, it looks like we have addition, which is going to become multiplication. We do have coefficients in front of our logs, so let's bring those forward as exponents. So this is going to be log 1/2. This is going to be squared, plus log 3/5 is to the 5th power. So let's actually simplify this. Remember, this exponent goes here and here, same as that. So let's simplify it first. So that's going to be log of 1/4 plus, this will become log of, now 3 to the 5th power. I don't know that one by heart, but in my calculator, that's going to become 243. And then 5 to the 5th power is 3,125. Now these two can be brought together into multiplication. So it's going to be log of 1/4 times 243 over 3,125. Then the next step we can do is let's multiply straight across. So this is going to be log of 243 over 12,500. Now this is a base 10 number, so really what it says is 10 to some power is going to equal this value. I will tell you, having to simplify this one is going to be beyond our scope, so for now let's just keep this answer in the logarithmic form and not make this one a single number. And what if you have to condense when it's natural logs? It's nothing different. Again, we do have a coefficient, so let's bring that forward. And this is going to become the natural log of t to the 1/3 plus the natural log of 5. Additions multiply, so natural log. I'm going to put the 5 first as a coefficient and then t to the 1/3. And this is a single logarithm. We can't get a numerical answer because we do have a variable in there, so that is our final answer.